it has. Okay, descending limb of loop of henle, descending loop of vasa recta, ascending limb of vasa recta. Okay, so the flow of filtrate in between the loop of henle and vasa recta in their respective limbs causes counter current mechanism. What is that called? Counter current mechanism. It helps to produce the concentrated urine. The flow of blood through the two limbs of vasa recta is also in a counter current pattern. In the vasa recta also, the flow of blood is in the two limbs of vasa recta, descending limb and ascending limb, in a counter current pattern. The proximity between henle's loop and vasa recta, okay, and the counter current in them help in maintaining an increasing osmolarity. As I said earlier, the flow helps to increasing osmolarity towards the inner medullary interstitium. Okay, so if you take the cortex region, in the cortex region the osmolarity will be 300 mass mole inverse. Okay, and medulla was divided into outer medulla and inner medulla. In the outer medulla it will be around 600 mass mole inverse. In the inner medulla it will be around 900 mass mole inverse. Below the inner medulla, you can see below the inner medulla it will be around 1200 mass mole inverse. Okay, I am writing here. In the cortex region, please look at here. In the cortex region, osmolarity will be 300 mass mole inverse. Okay, in the outer medulla it will be 600 mass mole inverse. In the inner medulla it will be around 900 mass mole inverse. Below the inner medulla it will be around 1200 mass mole inverse. This is the concentration gradient of the, okay, or osmolarity of the interstitium or filtrate. Now this is gradually caused by sodium and urea. This is gradually caused by sodium and urea. Gradually caused by sodium and urea. NaCl is transported by the ascending limb of loop of henle. Okay, NaCl is, imagine it is transported by the ascending limb of loop of henle. Okay, which is exchanged with descending limb of, descending limb of vasa recta. Descending limb of vasa recta. Okay, NaCl is returned again. Here vasa recta has a NaCl. The NaCl again, it will be what will happen? It will be returned to the interstitium. It will be returned to the interstitium. What is that? Interstitium. It will again enters into the interstitium. Okay, interstitium. Okay, it will again enters into the, from the vasa recta again NaCl is returned to the interstitium. What is that? Interstitium. Return to the interstitium. Okay, and by the ascending portion of vasa recta, it will return to the interstitium by ascending limb of vasa recta. In this case, similarly, small amount of urea, if you carefully see, small amount of urea, if you carefully see, it enters the thin segment of ascending limb of loop of henle, ascending limb of loop of henle. Now the urea is finally reached to the ascending limb of loop of henle, which is transported back to the interstitium, How this interstitium looks like, I will show you in the diagram, no issue, by collecting duct, by collecting tubule. The above described transportation of substances, okay, in between special arrangements of Henle's loop and vasa recta is called the countercurrent mechanism. Okay, this mechanism helps to maintain concentration gradient. This mechanism helps to maintain concentration gradient of the interstitium and fluids. Okay, you can see the interstitium here. And this is the cortex region, and that contain interstitium, 300 mass mole inverse. This is the medulla, outer medulla, 600 mass mole inverse interstitium, and its